First, we take fluid flow fluent and add it to our system. Then, with this system, we go to New Design Model Geometry. With that loaded, we hit the Z and select the XY plane. Go to Sketching. First, we need to create a circle, center, then a rectangle, and after this, we will dimension it. The circle will have a radius of 1 meter, diameter 1 meter from the top to the bottom of the from the sides of the square will be 50 meters. From the top from the top for the height of the rectangle will also be 50 meters. From the x-axis to the top will be 25 meters. Then, of course, from the y-axis to the sides will also be 25 meters. Then we go to create the surface from the sketch. Generate. There we have our surface. So we go back and then we go into mesh. With that open, we go to mesh, insert, method. Then we're going to start with a regular triangular mesh. Generate that. After that, you will go insert, sizing, select the edge, the center, type, number of divisions, the number of divisions is 200, capture curvature is no, behavior is hard, no bias, generate. That'll look like that. Then we will add an inflation geometry, be this. Boundary will be here. Inflation option, first layer thickness, first layer height, 0.003. Maximum layers is 100, and we keep the standard growth rate and hit generate. Now it looks like this. Then what we will do is we will update the default element size to 0.15 meters. Then we hit generate. Alright, then it looks like that. And we will go back to the workbench, hit update. Then we go back into the mesh to create our name selections. Insert, or click this one. Create name selection. This will be the velocity inlet. Then this will be the pressure outlet. The top and the bottom will both be symmetry. And lastly, we have this in here, which will be wall. Okay, I'm going to go back, update. Then we go into setup, double position, 2D. This first one will be the inviscid flow. Then we'll go to models, viscous, change it to inviscid. Materials, ensure that it is air, which we will keep as is. Then we go to boundary conditions, inlet, velocity inlet. Here, the velocity for the velocity inlet will be 5 meters per second. Outlet will be a pressure outlet, symmetry, symmetry. Wall, wall. We'll go to our reference values to make sure everything is correctly set up. Here it is not, so we will make that 5. Methods. We'll go to simple, gradient, least squares, pressure will be presto. Again, just going to double check our reference values. Okay, initialization, we will initialize. Then we'll run the calculation with the number of iterations being set to 1000. And then we will calculate. The calculation is complete. We go to reports, forces, and we will create a force report. That will be for that. And then for plots, we will create one, first an XY plot. And here you can select write the file to export it to Excel. This will be the pressure coefficient for the wall. Save and plot. That looks right. Then create a new one. We'll call this velocity variation. Again, you can write the file if you wish. Velocity, velocity magnitude, wall, save and plot. That looks right. We go back, go to results. All right, then we orient it correctly, and we're going to create a contour. This will be the pressure contour. Locations, symmetry, variable pressure, number of contours. We'll set it to 110. Whole domain symmetry. Actually, we'll set it to symmetry 1. Yep, there we go. Apply. Yeah, that looks about right. And deselecting that, we will create another contour. This will be velocity. Locations, symmetry 1, variable velocity u, global 110. That looks right. Deselect that. And then we will go to streamline, create a new streamline. That start from velocity inlet, number of points. We'll set it to 250. Variable velocity, apply, and that also looks about right. With that, the invisit is complete, and we're going to save. Then we're going to rename it to invisit, so that way we remember. And of course, from the setup section, we're going to duplicate. We're going to call this laminar. From then, we can close out all this stuff. That's odd, but we got what we got. Double precision. Setup. With this loaded for laminar, we're going to change this from viscous invisit to viscous laminar. Materials, fluid, air. Here we will amend the density to be simply 1, and the viscosity will be 0.05. Change create, close, keep everything else the same. Double check the reference value, so it should be 1, velocity 5, the viscosity will be 0.05. Yeah, that looks correct. Compute from velocity inlet. And so surface body. Methods. We will keep it as simple and presto. Then we initialize. We calculations. Get 1,000 iterations. Calculate. With the calculations complete, we can then make our force report. And plots. Same thing. New. Call it pressure variation. Pressure, static pressure, we'll change that to pressure coefficient from the wall. You could write it to a file if you want. Save and plot, that looks good. Then another one, new. Velocity variation from the wall. Select velocity, velocity magnitude, save and plot, that looks good. Then we will go back to the workbench and look at our results. Since we duplicated it directly rather than doing anything else, we were able to keep the contours and streamlines directly. Lastly, we will go back to the workbench, duplicate it one more time, call this turbulent. And we'll just close out. Or not. Well, go back to the setup. Double precision, 2D start. With the setup menu loaded, we'll go to models, viscous, change it from laminar to spellart. Materials, fluid, air, And here we're going to amend it slightly so that the viscosity is 5 to the -5, or 0.00005. Density will still be 1. Change create, close. Then we'll go to boundary conditions, inlet, velocity inlet. Velocity magnitude will be 6. Apply, close. Double check the reference values. See that they have not updated. Repeat from velocity inlet. Then we go to methods. We will keep simple and presto. Initialization, we will initialize. Run calculation. Number of iterations 1,000. We'll calculate.